What's up, math scholars? Thanks for joining me for part 1 of our study guide video. I'm not sure how far we'll get. I'm hoping we can get half of it today and half of it tomorrow, and then take Friday to do some group work and a practice exam on Polaris. There's a little practice exam where you can choose your groups wisely, like we did a couple weeks ago, last week. All right, number 1. What do they want us to do? Graph it? Easy peasy. My suggestion would be just head to that calculator and graph it. I mean, there is a Vertex formula that we could calculate, but the easiest bet's probably just to graph it. It's opening up, and that y-intercept's kind of up there by 3. But this will be a multiple choice test, and you'll just pick the one that looks like it's the closest to the graph that you're seeing. And just a refresher, it is opening up because that positive 2 out front. Remember our parabola lines? Those were always fun. I don't think there's anything from that problem I would put on my formula sheet. And I forgot to mention, as far as like the order of the problems on the study guide, it's going to be the same order on the actual exam. So number 1 will be a graphing problem. Okay. So we have to find the vertex, the axis of symmetry, and the X-intercepts. Do you remember what form this is? Just to refresh your mind, we had standard form. We had intercept form, and we had vertex form. What we're looking at right now is intercept form. Intercept form, you need an R there. An intercept form can give you the 2 intercepts just by looking at the problem. We called them the P's and Q's. Does that ring a bell at all? P's and Q's. So in this case, the P value would be 3, and the Q value would be 7. It's the solutions of those binomials. And the vertex formula, if you're in intercept form, is P plus Q over 2. That'll give you the X value of the vertex. You'll just have to plug it back in to get the Y value of the vertex. So in this case, I would do 3 plus 7 over 2, and then that'll be the X coordinate of my vertex. So 10 over 2 equals 5. So 5 is my X coordinate of my vertex. Do you remember how to get the Y coordinate of your vertex? Starts with P. Plug it in. Very good. She remembers. So we're going to take that 5. We're going to plug it back into the original formula everywhere we see an X. Oops. So it ends up being negative 2 times 3 times negative 2. 12. And your axis of symmetry always is just that X value of the vertex. So we need to kind of look for our choices now. The vertex. Did I mess up? I must have. There's no choices that are 5, 12. Oh, it's 5, 8. How did I mess that up? Negative 2 out front times 3 times negative 2. I'm messing my calculations up. Let me pause the video while I figure out what I messed up. Alright, we did figure it out. I was plugging in my formula wrong. There should be a 3 right here. I think Amelia found my mistake, so Amelia gets a ticket. But yeah, so it's negative 2 times 2 times negative 2. And that's 8. I think we're good now. Which choice has 5, 8, and axis of symmetry of 5, and intercepts of 3 and 7? B. All right, number 3, we're factoring. We have a whole bunch of techniques. Old-fashioned, box, grouping. I mean, it's ringing a bell?
Old-fashioned.
Yeah, old-fashioned for sure, because there's no number out front. We've done this so much, I think you're probably good at it by now. What numbers multiply to positive 81 that add up to negative 18? X minus 9 and X minus 9. Alright, what are the solutions? I probably personally would just factor this using my old-fashioned factoring technique and then solve both of the binomials. You could test all these solutions by sticking them in for X, but I almost feel like it would take more time. What numbers multiply to a negative 16 that add up to a negative 6? What is it? Yep. -8, and +2. And so that makes the solutions of the binomial a +8 and a -2. So refresher on solutions. Solutions are whatever values could go in for x that would make that binomial equal to 0. So what we go with? B again? A lot of B's. Alrighty, so we're on number 5. We're still factoring. I always look for a common monomial first. Do you see one? So what method are we thinking?
Box.
The box method. When you have that 5 out front, that forces it to the box.
So confident, and then I was like, no.
We're live on the video, thanks. Alright, so we're going to put a 5x squared in the upper left box. You're going to put a 21 in the lower right box. And just to refresher, you want to take that 5 and multiply by the 21. It's a pretty big number.
Amelia, why?
105, live on the video. Now we need to pick two numbers that'll multiply to 105, but yet add up to -22. That might take a little experimenting. I would try 5. So is 5 and 21 going to do it? No. We're going to start experimenting. I'll try dividing it by 15. Is 15 and 7 going to do it? 15 and 7? Yes, if you make them both negatives. -15 and -7 will add up to that -22 that we need. At this time, we pull out our common factors in the top row. What do you have in common? A 5. A 5 and an x. And then I just reverse myself around. So 5x times what is 5x squared? And 5x times what is -15x? And then x times what is -7x? So this is one of those beware of the double negatives. I just like saying that. So 5x minus 7 and x minus 3.
Leave a like and comment below.
Leave us a like and comment below and hit subscribe. I have not checked how many subscribers I've had recently. All right, number 6. This is still factoring. It's a technique we haven't seen yet today, though. Do you remember what it's called? I call this technique difference of perfect squares. In difference of perfect squares, you really need to remember that in your binomials, you're going to have 1 plus and 1 minus, or it won't work. Your binomials need to be conjugates. So right off the bat, I can absolutely tell that like this is not going to work because they're both minuses. And then the rest are pluses and minuses. Let's go ahead and do the square roots, though. What's the square root of 25x squared? 5x. And what's the square root of 9? 1 positive 3 and 1 negative 3. So yeah, these aren't perfect squares, though. They're answers of what you get when you get perfect squares. So D. All right, we're on number 7. We're still factoring. I always like to look.
Yeah.
I always like to look for a common monomial first. What common monomial can you divide out of 36, 93, and 60? I'm thinking a 3 and a u to the 4th. So we're going to pull a 3 and a u to the 4th out front. So 36 divided by 3 is 12. That would leave 2 u's inside because I took 4 of these 6 u's away. 93 divided by 3 is 31. That would leave 1 u there because we had 5. We took 4 away. And then 60 divided by 3 is 20. We still have to factor that stuff. What factoring technique can we use? Box method. Very good. Still on track with my answer key. Yep. Alright, so we're going to put a 12 in the upper left box. 12u squared. We'll put a 20 in the lower right box. These are all positives. This will be easy numbers to work with. 12 times 20. 240. And now we need to find numbers that multiply to 240 that add to 31. So I'm just going to do a brainstorm list. 24 and 10, would that do it? No. 12 and 20. Oh. 15 and 16. Awesome. That's on our 3rd try. I just try things until I get it. And they're all positive, so that's going to be good. What does the top two have in common that I can divide out front? A 3 and the u. So let's just reverse our Punnett square. 3u times what? Is 12u squared. 4u. 3u times what? Is 15u. And 4u times what? Is 16u. So our final answer, you don't want to lose your puppy, that 3u to the fourth from earlier, but then we've got a 3u plus 4 and a 4u plus 5. What are we going with? Is it B again? Yeah, it seems like it's always B.
Yeah.
Huh. Fascinating. All right, since this is a multiple choice test, honestly, I would probably just type this in and see what decimal is equivalent. I mean, I can show you the mathematical way of doing it, of course. No. So the calculator way of doing it is type it in and see that it is 420.55677. Then figure out what other one is equal to that. So it's not A. It's not B.
Oh, I see what you're doing.
It's not C.
It's D. It's D.
I want to verify. It's D. And since a lot of you are purists and you probably want to see the math way of doing it, I'll do that real quick. It won't take me long. I'm going to put the 578 and the 34 underneath one big jail together. And then I'm going to break guys out of jail. Honestly, it's probably my best bet. Rather than make this number huge. You can make this number huge if you would like. Do you want me to make it huge or just break guys down? Yeah, if I would multiply these together, it would be 19,652, so I'd rather just break them down. I know that 34 is 17 times 2. I can divide the 578 by 34. It's 34 times 17. And that's going to give me another 17 times 2. So you can break two 17s out of jail. This will come out. This will fall in the hole. You can break two 2s out of jail. This will come out. This will fall in the hole. So if you have a 3 out of the jail, a 17 out of the jail, and a 2 out of the jail, you will multiply them together. And that's 102. Complete confusion? What are you confused about? Just tired. You want to basically break them down and bring them out in groups of 2 because this is a square root problem. And when they come out, one always lives and one always falls in the hole. And then this guy had to stay in because he couldn't get a friend. All right, number 9. What would be step 1? This is when we always play the game. What do you think we should do first, Taylor? Subtract the 36. I agree. So we're going to subtract the 36 to join the 183. What is it? Oh, thanks. What do you think we should do next, Logan? Good. Me neither, but I have a calculator in my hand. 49, thank you. And what do you think we should do next, Zoe? Good. So we're going to go with plus or minus 7. C, our first. All right, looks like we're adding some complex numbers, so we're going to add their real components. 5 and -1 is real. And then we're going to add their imaginary components. -3i and -2i is -5i, and it's that easy. Go back to the previous problem. Okay. Okay, this is one where it's called Rationalize the Denominator and get all the i's out of the denominator and all the radicals out of the denominator. When we did problems like this, we used conjugates. It's probably one of the harder ones on the whole exam, so if there's any problems you want to copy the whole entire problem onto that note sheet, it would probably be this one. So first off, you kind of set it up so that you can put a conjugate of the denominator over here. So the conjugate of my denominator is 7 minus 6i. And I have to put the same thing up above. That's just kind of the rule, so you don't change the overall value of the original. Now it looks like on the top I'm going to have a full-out foiling problem. I know. So it's going to be first times first, which is 28. Outside times outside, -24i. Inside times inside, 14i. And last times last, -12i squared. And I don't know if you guys heard on the video, but a student did shout out, isn't I squared equal to -1? It absolutely is. It is something to remember. I by itself is equal to the square root of -1. So whenever you see it, when I would do this in class, I'd go whoop, whoop, whoop. What's that alarm mean? That alarm means you want to replace all -1s you see, or all I squareds you see with a -1. So that'll make that a positive 12 at the end. I'll go ahead and do the bottom before I combine all my like terms. 7 times 7 is 49. And 6i and -6i and -36i squared. Whoop, whoop, whoop. What's that alarm? Got to replace that I squared with a -1, making it a positive 36. And here's how I combine my finals. The 28 and the 12 is going to be what? Alright, sorry, I paused the video. I was panicking because I looked above at the choices and didn't see any 40s, and I freaked myself out. But we're actually still on track, because what we have here will reduce down. I can write it like this, 40 over 85 minus 10i over 85. And the 40 over 85 can reduce down. Those numbers are both divisible by 5. Try it out. What's 40 divided by 5? 8. What's 85 divided by 5? 17.
It's B.
Same thing happens over here. Divide the top and bottom by 5. 10 divided by 5 is 2. 85 divided by 5 is 17. So Logan said it's B. He's right. So yeah, sorry about my panic. We were actually on track all along. So we're on connection schedule today, which I had forgotten about. So we're actually going to end the video right here and pick up again with our next video. Thanks for watching.